To understand how to use equations of motions, let's try and solve a problem. So I'm going to take the task as an example here to solve the problem. So here is a picture of me dropping a ball. This is the velocity time graph and the acceleration value which I got from my recording. So what we'll do is we will try and use the equation of motion and find out the height from which I drop the ball. So which means basically I need S, right? I need S. Now before solving any problem, I told you that it is important for us to define the axis. So let me quickly draw a diagram. So let's say this is the point at which I drop the ball, X here, and I'm going to consider the position to be positive downwards, right? And it's 0. So which means the initial position is basically 0. So that's the first step which we have to do before solving any problem. Define the axis. Define the axis and the direction which it is going to be positive and negative. Done. And the question here is to find out the height from which it is dropped. Basically, I'll have to find the change in position. I have to find the change in position. This is displacement. Agreed. Now, in order to do that, I'm going to take a few data points from the analysis which I did already. So as you see here, the acceleration which I found was 10.7 meter per second square. Now, before that, I have to tell you this number is what we call as acceleration due to gravity. This number, which is 10.7, is given a meaning which is called as acceleration due to gravity, g. But you would have heard the value of g to be 9.81 meter per second squared, or rounded off to 10 meter per second square. I know that. So what had happened in my case is the result which I've got here is it is inaccurate. It has got some error in it. There could be lots of reasons behind it. I'm not going to discuss about that, but for the scenario which I had used, this is the acceleration due to gravity which I found. So I'm going to use the same data point here to find my change in position. So the acceleration which I have is 10.7 meter per second square. Now, is there any other data which I can find? I can actually find time as well. So let me show you what's the time here. Hold on a minute. Yes. Now let me scroll and find. If you're able to see this part, you'll have to wait. If you check it very closely, I am releasing the ball when this turns to be 0. Yeah. This is the point at which I release the ball. That has to be 0. Okay, I think I moved a frame ahead. Yes. Now, if I can show you, see, this is the frame at which it is hitting or maybe just about to hit the surface. And the time, as you see here, is 0.6 seconds. Okay, right? So quickly going back to the other screen. So the time is 0.60 seconds. Yeah. Now I know that I dropped the ball, which means the initial velocity is 0 meter per second. See, this is step number 2. First step is to draw the axis, draw a diagram so that you clearly represent the axis and the point at which it is going to be 0. The second step is to clearly identify the knowns and the unknowns, which is done already here. We have it now. So now the third step is to find out what equation should I use to find S. Now to quickly write down the equations, the first equation which I have is V is equal to U plus AT. Second one is S is equal to UT plus half AT squared. Third one is V squared equals U squared plus 2AS. The fourth one is S is equal to U plus V times T whole divided by 2. So these are the four equations which I know of. So based on the knowns and unknowns which are given to me, if you think about it, I have to use equation number 2. So equation number 2 becomes ut plus half at square. So 0 times time plus half times 10.7 times 0.6 squared. So basically S becomes half times 10.7 times 0.6 whole square. Let me quickly put that in the calculator. 0.7 divided by 2 into 0.6 into 0.6. Okay, the answer which I'm getting is the one which is given by the calculator as such without rounding off is 1.926 meter. Now don't forget, it's time for us to round it off, right? So I think this has got 3 significant figures. This is actually given as 0.600 second. Yes, but I'm not sure whether I can take so many significant figures there. So what I'll do is I'll stick with 2 significant figures, or it's up to you guys. So if you want to stick with 3, so it's actually going to be 1.93 meter. Now if you go back and check the video of me dropping that ball, the actual height was 2.0 meter. Hope you see they are pretty close to one another. The difference between these 2 points, I mean, there is a difference of 7 centimeter. There are lots of reasons possible. One is the acceleration due to gravity, which I found 10.7, as I just told you, that itself has got some uncertainty associated with it. So that could be one reason. And the other reason is 0.6 seconds. As I just told you, we really can't decide the point at which the ball is just about to touch the surface. So those 2 points are the reasons why there is a difference of 7 centimeter in the height. And hope this also helps you to appreciate the concept of mathematical modeling. Using this equation of motion, I'm actually able to predict the height from which the ball was dropped given the other quantities. Right now, meanwhile, I also wanted you to understand the importance of these 4 equations of motion. Now, these equations of motion are also called as Shewhart equations. As you see, these are nothing but the various variables present in the equations. S for displacement, U for initial velocity, V for final velocity, A for acceleration, T for time. Now, if you observe very closely, these equations, these 4 equations put together, they are special in a manner. What does it mean is, so if you look at this equation, you have S missing. This one, V missing. So this one, you have T missing. This one, you have A missing. Actually, there is one more equation. There is one more equation, 5th equation, which is not in a syllabus. Which is not in a syllabus, I repeat. The actual equation is S is equal to Vt minus half at squared. Okay, so that equation, if you look about it, you don't have U in it. So basically, what I'm trying to tell you is, all these equations put together, there is one variable which is missing in them. So, using these 5 equations, you can solve any given situation as long as you are given 3 of the variables involved in it. If you're given 3 of the variables involved in it, You can find the fourth and the fifth one using one of these 5 equations. Let's do more problems so that you get more clarity on this.